Understanding gravity is the key to understanding creation. I'm going to talk about gravity as negative energy. When we look up at the night sky, most of us have wondered, how did all those stars get there? Well, how did the planets get there? What is all this stuff around us? Why do we have a universe of something rather than nothing? And what is nothing and what is something? Well, physics tells us that nothing is an unstable state, that it doesn't stay nothing for long, and that something, the stuff all around us, is a natural state of existence. But what is something? Well, for example, this marker is something. In terms of physical terms, it's energy. Einstein discovered that E equals mc squared, that energy is equal to mass times the speed of light squared. So mass is just a very concentrated form of energy. But how do you get something from nothing? I mean, doesn't physics tell us that you can't create something from nothing, that it violates the law of conservation of energy? So let's consider that for a moment. Let's say nothing mathematically is zero, and that the matter in the universe, the stuff we see, we can represent by mass times the speed of light squared, Einstein's famous equation. But how do you go from zero to that? The laws don't allow that. But there's a loophole. If we add up all the energy, there's a negative energy that we'll call E sub G, and G is for gravity. This is a gravitational energy, and it's easy to calculate. It can be calculated based on the Hubble radius, the mean density of matter, and how fast this matter is expanding. It's not hard to calculate, but when the calculation is done, physicists find that the negative energy of gravity balances the positive energy in the universe, resulting in a universe where the energy sums to zero. So this is an interesting equation. It says on this side we have nothing, on this side we have something. We have two somethings. We have a positive something and a negative something that cancel each other out and give us a universe where the total energy adds up to nothing. So let's explore this term, the negative gravitational energy, in more detail. Let's do a simple gravity experiment. I'm going to hold this marker and I'm going to release it and let it fall. We see that as it falls, it gains an energy of motion, or kinetic energy. When at the top, we can say it has zero kinetic energy, and when I release it, it falls, and as it falls, it gains in kinetic energy. Now, where did that energy come from? I mean, we know that energy can't be created or destroyed, so where did that come from? Well, let's analyze that situation. Let's say that I hold an object up in the air, and then I release it, and I let it fall towards the ground. So at a time later, object's down here. So at the starting point, we can say it has zero energy of motion, or zero kinetic energy. So we'll say the kinetic energy is zero. But it also has gravitational energy, which we'll call GE. And before we release the object, we can say the gravitational energy is zero. Now this is just a reference point. We could have said the gravitational energy is -5 or -7. It really doesn't matter. The result comes out exactly the same. So as the object falls, it gains in kinetic energy. And we might say maybe the kinetic energy here is increased from 0 to 1. But the gravitational energy has decreased. It is decreased by an equal amount, -1. So that the total net energy of the system remains at 0. Before we release the object, we have these two energies equal 0. As we release the object, energy is conserved. We get an increase in kinetic energy balanced by a decrease in gravitational energy, and the net energy of the system remains at zero to conserve energy. Now, as the object continues to fall, at a later time, this maybe goes to plus 4 minus 4 equals 0. Now, this tells us, this negative part of the equation tells us that gravity is negative energy. Let's do another gravity experiment. This marker has a certain amount of mass. And we know from Einstein's E equals mc squared that mass is also energy. So this marker has quite a bit of energy. In fact, we could use this energy as fuel. And we could turn this marker into a rocket ship and use the mass energy as rocket fuel. And if we do that, we could accelerate this marker, burning its energy as fuel, away from the universe. Let's analyze that situation. Let's say that we have a universe here, and that we have this marker. And I'll draw it extra large. And that we're burning the marker's energy as rocket fuel, and we're accelerating or moving away from the universe. And a time later, we've burnt some of the mass as fuel, and it becomes smaller. A time later, still smaller. And eventually we'll have zero energy and corresponding zero gravity. At this point, let's say that the mass energy is, let's say it's plus 10 units of mass. And we know that mass and gravity go together. You can't have gravity without mass, can't have mass without gravity. So this mass corresponds to minus 10 units of gravity that offsets this mass somewhere in the universe. Now, as we accelerate, let's say the mass at this time is plus 5, and the gravitational energy is minus 5. Time later, perhaps this is 1 and minus 1 gravity. Now, eventually, as we burn all the fuel, we end up with zero mass, zero gravitational energy. So this marker, as we burn the energy as rocket fuel, eventually the mass is uncreated, and we also uncreate a corresponding amount of gravitational energy. So this marker has been uncreated. Now, if we can uncreate this marker, we can take any object in this universe, and we can use this mass as fuel, and we can burn the fuel and travel away from the universe. And eventually, it'll go to zero. When we do the same thing, this little chunk of matter. And if we continue to do this, we can uncreate the entire universe. Now, if we can uncreate the universe, now we can start to understand how the universe can be created. Let's explore this. Let's say that long time ago, more than 14 billion years or so, before the universe existed, before time existed, before space, we have zero matter, and we have zero gravitational energy. We have zero total energy. So we have nothing. Now we know from quantum physics that nothing is an unstable state. Heisenberg's uncertainty principle tells us that nothing does not stay nothing for very long. In fact, in laboratory experiments, we find that virtual particles come in and out of existence all the time. And let's say that we have a virtual particle event or a Heisenberg event. It creates a very small amount of mass energy or positive energy. And I'll call this amount of energy 1, where 1 is a symbol for a very tiny amount of energy. At the same time, we create a corresponding amount of negative gravitational energy. So the total energy of the universe still sums to 0. Now, if this can happen once, it can happen again. So time later, let's say that we have 2 units of positive energy minus 2 units of gravitational energy equals 0 total energy of the universe. So we can see how a universe can evolve from nothing, where the positive energy always balances the negative energy for all points in time. So we can see that this negative part here, this negative gravitational energy, is what allows the universe to come into existence. Understanding gravity is the key to understanding creation. I'm going to talk about gravity as negative energy. When we look up at the night sky, most of us have wondered, how did all those stars get there? Well, how did the planets get there? What is all this stuff around us? Why do we have a universe of something rather than nothing? And what is nothing and what is something? Well, physics tells us that nothing is an unstable state, that energy is equal to mass times the speed of light squared. So mass is just a very concentrated form of energy. But how do you get something from nothing? I mean, doesn't physics tell us that you can't create something from nothing, that it violates the law of conservation of energy? So let's consider that for a moment. Let's say nothing mathematically is 0, and that the matter in the universe, the stuff we see, we can represent by mass times the speed of light squared. Einstein doesn't stay nothing for long, and that something, the stuff all around us, is the natural state of existence. But what is something? Well, for example, this marker is something. In terms of physical terms, it's energy. Einstein discovered that E equals mc squared.